In this video, we're going to talk about computing integrals using areas. So we've talked about how the integral represents, a definite integral represents the net area under a curve. And usually we use definite integrals to actually compute areas, but there are some areas that we can actually compute on our own without needing to resort to integrals, and we can use those ideas to actually figure out the value of a definite integral. And so we're just going to do two examples of this idea. So first we want to take the integral from 0 to 1 of the square root of 1 minus x squared dx. So we want to compute this integral. So now what we're going to do is we're going to notice first what the graph of the square root of 1 minus x squared is. So we want to figure out its graph. And so we're going to set y equals to the square root of 1 minus x squared. Now if you don't know what its graph looks like, I'm going to just rearrange things to make it a little bit easier to see. So if y equals the square root of 1 minus x squared, then y squared equals 1 minus x squared. Well, x squared plus y squared equals 1. And this, hopefully you know, is the graph of a circle. And so the graph of the circle x squared plus y squared equals 1 just looks like the following, if I can draw a circle. But now this is the graph of x squared plus y squared equals 1. But that's not quite what we had. We had y equals the square root of 1 minus x squared. And so by squaring both sides here, when we did this step right here, we ignored the fact that square roots don't give out negatives. And so the graph of the square root of 1 minus x squared is just going to be the top half of this graph. So I'm going to draw the circle again, but the top half of this is the graph of y equals the square root of 1 minus x squared. And then for those that are curious, the bottom half is the graph y equals negative square root of 1 minus x squared. Okay, and so what we're looking at then is the graph of the square root of 1 minus x squared is just the top half here. And we wanted the integral from 0 to 1, so drawing our picture one more time, we have the graph of y equals the square root of 1 minus x squared, and we want the integral from 0 to 1 of this, which is just going to give us the area from 0 to 1 under the curve. So it's just this piece right here. But notice, we went through all that work to explain that this is a circle of radius 1, and we're just looking at a fourth of it. And so this integral is just the 1/4 of the area of this circle. The area of the circle is pi r squared. The radius is 1, though. And so pi is the area of the entire circle. So the entire circle has an area of pi. We're looking at 1/4 of it. And so the quarter circle's area is pi over 4. And so then the integral from 0 to 1 of the square root of 1 minus x squared is just going to be pi over 4. And we're able to compute this just using that we know the area of a circle and drawing the graph. And so this is one place where we can use an area to figure out what's going on. Now this next example is easier to graph, but a little bit more thought goes into the integral part. So we're going to take the integral from 0 to 3 of x minus 1 dx. And so this is, again, it's the net area from 0 to 3 under the curve x minus 1. So let's draw the graph of that curve. And so we only need to start at 0, and so we're going to have negative 1. And then we go up 1 over 1, just following the fact that we have slope. It's a straight line. And so the graph looks something like the following. I didn't draw that perfectly, but the graph looks like this from 0 to 3. And now we want the net area under the graph, and so this piece from 0 to 1 is going to be negative area because it's below the x-axis. And from 1 to 3 is going to be positive area because it's above the x-axis. And so now, to compute this integral, we want the net area here. So we're going to take this piece here, which I'm going to call A1. This is positive area. And this piece below, which we'll call A2, is negative area because we treat below the x-axis as negative. And so the sum of these two areas, though, will give us the net area from 0 to 3. And so because of that, all we have to do is find the area of these two triangles and combine them, treating A2 as negative, to get our area. So to kind of summarize, the integral from 0 to 3 of x minus 1 dx is going to be this area 1 minus area 2, because it's the net area under the curve, and area 1 is above the x-axis, so it's treated positive. Area 2 is below, so it's treated negative. Now, the area of the triangle is 1/2 base times height, so we have 1/2 base. So the base of A1 has a distance of 2 times the height. The height of the A1 triangle also has 2. And then we have minus A2's area, which is 1/2 times the base. The base is 1, and the height is 1. So we end up with 1/2 times 4 minus 1/2. And so we're just going to end up with 2 minus 1/2, which is 3/2. And so the integral from 0 to 3 of x minus 1 dx is just going to be 3/2. And so we're able to compute this area again, just using the fact that we had two triangles here and we were using the idea of net area. Just one final example. We talked about this before, but if you take the integral from some value, I'm just going to go 0 to 2 of a constant, where c is any constant, you can get this graph, this area, this integral, using just a graph. And so if we draw the picture, the graph of y equals c is just a straight line. And if we're going from 0 to 2, that means we're just going, we'll say this is 2. So we will just be computing this area, the area under the curve y equals c, from 0 to 2. But notice that is a rectangle. The base of the rectangle is 2. The height of the rectangle is c. And so this area is just going to end up being 2 times c. And in general, if I replaced 2 with any constant, with any value, so I'm going to replace 2 with, say, a, then the base has an area of a, and the height has area c, and so we get c times a. And so we're just looking at a rectangle in the case when we take the integral of a constant. And so you really just figure out how spaced apart are these two from each other. 0 and a are a apart, and you do that times c. So in general, the integral from a to b of c times dx is going to be, well, the height of this rectangle will be c, and then we're going to have b minus a, because that's going to be the width. And we talked about this formula before, that the integral from a to b of a constant c is c times b minus a. And this is how you can find it using areas. In the picture, we'd have something like the following. This is a, this is b, and this is c. And so we'd just be finding the area of this rectangle, which is going to be c times b minus a. And so that is how we can use areas to help us compute integrals.